My name is Marcin Skok. I'm a research associate at the University of Cambridge, and today I'll tell you about one problem that we should be solving right now.
In this project, I would like to focus on skin lesions. Diagnosis of many of the neglected tropical diseases, such as yaws, leprosy, or leishmaniasis, is based on the appearance of patients' skin. Regretfully, these diseases can manifest in multiple ways, and thus diagnosis by a non-expert is difficult. Experts, however, are rapidly disappearing. The diseases are not as prominent anymore, and current medical doctors don't get to see them as much. And if they do, they see only one variant, maybe two in their training. Furthermore, the doctors that work with these diseases get so desensitized they see them everywhere. Clinics and hospitals where such patients are seen are notoriously overcrowded. Recent estimate shows that a specialist doctor in India spends less than 2 minutes per patient. On the flip side, doctors seeing so many patients in a day suffer from inevitable decision fatigue, and by the end of the day can no longer be relied to give their best in diagnosing the patient. I believe I have a solution to this problem.
I have more than 15 years of experience in computational biology and translational science, but at heart I remain a computer engineer.
One of the most promising techniques of the last few years is machine learning, especially deep learning. Through the use of involved linear algebra, we're able to make computers plan logistics, play difficult games, and understand visual information. It's no wonder then that it has also been applied to medical sciences. And using machine learning for analyzing skin lesions has already been done. It has been done in peer-reviewed papers. It has been done in student theses. Making it work for this application is just a matter of finding proper parameters and a proper training set. Will it work then?
I know that it works. I have built a working prototype.
In my prototype solution, I have used a very successful neural network architecture called the residual neural network, which has been already used for classifying human faces, photos of birds, and as far as the data that I have used for training is concerned, the negative data came from pictures of celebrities with healthy skins, whereas the positive data, the data of skin diseases, came from DermNet, New Zealand, Derm101, both having large corpora of dermatological information, and International Textbook of Leprosy, which contained a large amount of leprosy information. All in all, I had over 26,000 examples of human skin, out of which almost 13,000 diseased, but only 131 pertaining to leprosy. This is a Raspberry Pi, a single-board computer developed here in Cambridge. It costs about $35. It has a very low power consumption. Thus, it can be powered from a mobile phone charger or from a power bank. And that makes it perfectly suitable for deployment in field. Let me show you how it works with our leprosy lesion classifier. I've put my Raspberry Pi into a case, connected it to a power brick and to a screen. You don't need a dedicated screen or a power brick. You could use any old monitor you have, and this can be replaced with a mobile phone charger. I have also started my program. Let me start it here, and let's see how it works. First, we need to connect an image source. That could be a mobile phone that you took pictures with, or a camera, or, as in my case, a USB stick. Okay. And here are the images. The first two are the patients afflicted with leprosy. The other two are decoys. That's granuloma annulare, and that's a subcutaneous lupus erythematosus. Let's select the first image, second, third, and fourth. And now it's predicting. It will take around 1.5 minutes, so let me stop it now. And we're done. The network has assigned numerical values to each of the images. 1, how likely is it that the person is afflicted with a skin disease? And the other, how likely is it that the person is afflicted with leprosy? I want to compute the aggregate statistics. if we were to assume that all of the images came from the same patient, the network could compute the statistics means, etc., to tell us, on average, how likely is the patient to suffer from our disease of choice. And it could give recommendations. And that's how it works. The time to make this project happen is now. As humanity, we have unprecedented amounts of data that we can leverage. And we finally have technical competence to make that dream come true. I am the person to see this project through. Since year 2013, I have collaborated with foremost researchers in machine learning in the world. At Aalto University, Technical University of Munich, and University of Cambridge. Together with the researchers at Technical University of Munich, we have developed a deep neural network to interpret biological data and presented it at NIPS, the world's largest conference for machine learning, where out of 8,000 submissions, ours was one of the 55 chosen for our presentation. The other condition for success is the availability of data. In September this year, I will be speaking at the 20th International Leprosy Congress, where I will implore the field to contribute their data to this project. But the main reason why I believe that this project will succeed is involvement of American Leprosy Missions, one of the largest non-profit organizations dealing with leprosy research in the world. They have committed to contribute the historical backlog of clinical data from the hospitals under their auspices on 3 different continents. The future is bright. We have still plenty of work to do. We need to develop a better statistical model. ResNet may not be the best way to go. We need to work on implementation, user interface, to make it work on more platforms, to make it work faster and better. We need more data to make our models better. But the most important thing is, this thing is ready for deployment now. If we want, we can get it in the hands of clinicians all over the world tomorrow. And we could make lives of thousands of patients better with a single